So in the last class, we have discussed about which access modifiers we can apply on class. On class, we can apply one is abstract and the other one is final. On class, we can apply only abstract and final. We will discuss about final class later on, the next half of the presentation. First, we will discuss about abstract. So, here is one example given on abstract class. You tell me which type of classes are declared as abstract. So, in my knowledge, the abstract class is declared only in two occasions. One is if class contains abstract methods. If a class contains abstract methods, then such classes are declared as abstract. If class contains abstract methods, then such classes are declared as abstract. So, for example, if you come to here I have written one class called public class. There, I am not mentioning this abstract access modifier here. Public class, and some class name, some abstract class I have written. This abstract class doesn't mean that it is abstract class. I just written class name as abstract class. Public class, abstract class. And how many methods this class is having? This class is having 4 methods. M1, M2, M3, M4. This class is having 3 methods, M1, M2, M3, M4. And if you carefully notice, M3 and M4 are implemented methods. Implemented method doesn't mean that you need to write tens and hundreds and thousands of logic. If method, soon after the method declaration, if you open and close a flower basis, and if you provide a body, if you provide a blank implementation, blank body to the method, then you can call that method as implemented. Of course, we need to write logic in that, but it will be accepted as an implemented method. So if you are interested, you can write logic. The first 2 methods, M1 and M2, instead of having flower bases here, the methods having flower bases here, they were simply declared with semicolon. Semicolon means the methods are just only declared. They are not implemented. If class contains any such abstract methods, such a class must be declared as abstract class. And if class contains abstract methods like this, and if you don't declare class as abstract, you will get a compilation error. During Java C, the file name abstract class.java, and if you don't declare the class as abstract here, if you compile Java program, immediately you will get an error. Java compiler says the current class, the abstract class is found with 2 abstract methods, 2 unimplemented methods, 2 abstract methods. Hence, you declare your class as abstract or implement these 2 M1 and M2 methods. That is what Java compilation error will come. So, immediately soon after getting the compilation error, we will declare class as abstract. And this is one occasion where we can declare class as abstract. If class contains abstract methods, then we must declare class as abstract. If you don't declare, compiler will force you to declare your class as abstract. First point. And second point is, some developers from other object-oriented programming backgrounds like C++, Smalltalk, or other old object-oriented programming language backgrounds, other object-oriented programmers may sometimes feel that abstract class must contain abstract methods. But remember, in Java, an abstract class need not contain any abstract methods. Abstract class don't need abstract methods. Without having abstract methods also, we can declare class as abstract. So you may immediately ask me one doubt. Without having abstract methods, without having abstract methods, why we need to declare class as abstract? Okay? Class contains all are implemented methods. In class, all methods are implemented methods. No abstract methods exist. But still, we'll declare classes abstract. We'll declare classes abstract on our own favor. That nobody will force us, like compiler will force us to declare classes abstract. Because our class contains only implemented methods. No abstract methods are there. So whenever there are implemented methods, a class can be a normal class. But I want to explicitly declare my class as abstract. Why? So sometimes while designing the classes, some classes says that we are the most generic superclasses to many of our subclasses. Hence, we want to be declared as abstract basis. Give me an example. So if I want to give you an example, the example is in user interface programming. See, most of the programming languages are having user interface API. I started my learning when I was a student. I started my user interface programming learning with Visual Basic, followed by Power Builder, then followed by Power Builder, Developer 2000, Oracle Forms and Reports, we call it as 3 on Windows operating system, Visual Basic, Power Builder, and Oracle Forms and Reports, Oracle Developer 2000. 3 I have learned. The next I have learned little bit VC++. There I did user interface programming. Then finally I learned it into Java. In Java also we are having AWT, Swings. Now we are having JavaFX. These are all user interface programming API. So Java, in which I use user interface programming. And of course, some little occasionally I used user interface programming in Python also using Tkinter. And there are many other languages. Like if you go to Android is full of mobile-based application development, so it contains full of components only, user interface components. So you take any user interface component API, whether it may be, and I'm not comparing with Visual Basic or Power Builder because they are procedural languages. I'm talking about Java next to C#. C# is also an object-oriented programming language. It is also having a UI API. But I don't know how the UI components are written in C# or VC++. Coming to the Java, in Java we are having a couple of UI components, like say for example, label, text field, text area, checkbox, radio button, list box, drop down box, button, scroll bar. I counted nearly about 9 components. Tabbed pans, trees, spinners, sliders. I'm not counting all of them. I'm just counting only some basic components available in AWT. There were around some 9 to 10 components. If I go to Swings, you'll find 50 plus UI components. So Swings is a very advanced UI API in Java. I'm talking only about AWT. So 10 components are there. Across in all this, plus next to frame, applet, panel, they are containers. They are also components later on, they are containers. Panel, applet, frame, dialog, file dialog. Altogether we got some 14-15 UI component. I'm just taking only 10 classes, for instance. Out of in these 10 to 15 classes, the common properties required are set x, set y. The set x is a position where the component want to be visible on the screen. Set x horizontally. Set y in the y coordinate where the component want to appear. And set width, set height. How much width and how much height the component want to be visible. How many properties? So x, y, width, height. Background to change the background. Foreground to change the text color. Font to change the font. Enable, visible, editable, resizable, position. Wow, we got 4 properties. 12 properties. To modify 12 properties in each user interface component, we need 12 pairs of setter and getter methods. Means 24 methods. 24 methods in one class, like that around some 15 classes. Take 10 classes for example. 24 into 10 240. If it is 15, you can imagine 24 into 5 more again. So those many number of methods we need to write, setter and getter methods we need to write across in 10 to 15 components. 24 methods. So how time consuming for the developer to write these many methods repeatedly. I'm not saying that these are unique methods. These are duplicate methods. Same logic you need to implement across all the 24 methods. So instead of writing 24 into 10 or 24 into 15, in Sun Microsystem, when they developed AWT-API, they have written one superclass name called component. Public abstract class component extends object to supermost class. And in that component, all are implemented methods. All are implemented methods. All are implemented methods. No abstract methods exist. But the class is found declared as abstract class. Why? Because the component class claims that I'm providing 24 common method implementations to 10 or 15 or 20 user interface components, but those components are having some appearance like label, text field, text area, checkbox, square, radio button, circle, text field, grooving shape, rectangle, label, plain component, and the next radio button, circle, scroll bar, horizontal scroll bar with some thumbs to scroll left and right. Like that, every component is having some user interface look and feel. But to me, myself, I'm a component class. I'm providing 24 generic method implementation to any of the components, but I do not have any, user interface like UI, graphical appearance. So I don't want to be instantiated who component class is. So that is how the component class was declared as abstract class. Component class is having all implemented methods, but because the class do not want to be instantiated by the developers, the class is declared as abstract without having abstract methods. So nobody will force. Developer while designing the class itself, whenever the methods he is writing in a class whose implementations are more than one superclass, but that class do not want to directly participate in the object-oriented programming in the instantiation, then developer will naturally, developer or designer, whoever the design class, he will design and declare the class as abstract. So it is not mandated that abstract class must contain abstract methods. Without abstract methods also a class can be declared as abstract. But no doubt, if a class contains abstract methods, the class must be declared as abstract. So in this diagram, if you see, this class is having two abstract methods, M1 and M2. And if you just only declare and don't write abstract here, just write void M1, void M2, put semicolon, void M3, write body, void M4, write body. The moment you compile program, first two errors will come. Compiler says declare M1 and M2 methods as abstract. Because M1 and M2, compiler found that they are only declared but not implemented. The moment compiler notices that these two methods are only declared but not implemented, first compiler will force us to declare methods as abstract. It won't declare classes as abstract. First, it will force us to declare methods as abstract. Then, once again, if you compile, and two times you compile, one more time if you Java compile this program, then Java compiler says, because this class is having whatever may be the class name, without having abstract methods, how come you declare this class as a normal class? Then compiler will again ask us to declare our class as abstract. And because our class is having abstract methods, compiler will force us to declare class as abstract. So this is how public abstract class is formed with the two abstract methods and two implemented methods. Now you save this program and compile again. The program will be compiled, the class will be compiled. Once the program, class will be compiled. Then soon after completion of the writing of abstract class, we need to do on abstract classes. Abstract classes cannot be instantiated. Why abstract classes cannot be instantiated? Because the class is not fully implemented methods. The class has found some abstract methods, unimplemented methods. Suppose if you allow to instantiate abstract class, unfortunately if the client invokes ac.m1, suppose if client invokes ac.m3, no doubt, M3 is having implementation, that output will come. M4, that output will come. Suppose if client invokes ac.m1, what output do you give? Because the M1 and M2 methods are abstract. So, allowing developer to first of all instantiate the class itself is wrong. If you allow him to instantiate this class, then no doubt the client will call the M1 and M2 methods to whom there is no implementation. We cannot provide implementation to M1 and M2 methods. Right. So that is why the abstract class will be decided not to be instantiated. Suppose if you try to do that, if you write abstract class AC is equal to new abstract class, and if you compile Java C, abstract class, instantiate class. AC means abstract class or instantiated class. And this abstract class is subclassed into one subclass, AC subclass, public class, AC subclass, and abstract class subclass, AC subclass extends abstract class. And if you are trying to compile this subclass, we get a and this class will be compiled. But if you are trying to instantiate abstract class, you will get an error. You will get an error saying that abstract class cannot be instantiated. Then what you need to do? And the moment a developer found any abstract class, two things he should keep in mind. One thing he should keep in mind is, one, he should not instantiate the abstract class. Second, developer must provide one subclass, one implemented class, one subclass to abstract class. In that, all the superclass abstract methods must be implemented in that. M1 and M2 methods are implemented here. All the superclass abstract methods must be implemented here. M1 and M2 is mandatory to implement here. M3, M4 methods are already implemented methods. If subclass want to keep these methods as it is, don't rewrite anything. Suppose if subclass is not interested to keep this M3 and M4 implementations as it is. Suppose if subclass want to rewrite the M3 and M4 implementations for its purpose, then M3 and M4 methods can be overridden. That's what I'm saying here. Word M3 optionally we can override. M1 and M2 must be implemented. And what about word M5? Word M5 is not the method coming from the superclass. M5 is not the method coming from the superclass. So M5 is the own method of abstract class subclass. And M5 is the own method of this class. M1 and M2 are the abstract methods coming from superclass. They are compulsory to implement. And M3 method we can optionally override because M3 method is already implemented. If you are not interested, and if you want to modify, increase or improve the implementation of M3, you can improve M3 method implementation. Optionally we can override it. Mandatory implement these two. And M5 is having its own method. Know what you do? Now, is the subclass can be instantiated? Yes. Because if you don't implement M1 and M2 methods, then your class also becomes abstract. Be careful. Because M1 and M2 methods are implemented, if you compile this class, abstract class subclass, it will be compiled without giving any error. Automatically the class will be compiled. What do you do then? You instantiate subclass. You instantiate abstract class subclass. AC subclass, ACSC is equal to new ACSC abstract class subclass. After instantiating abstract class subclass, you invoke M1, M2, M3, M4 methods. This is correct. Abstract class subclass can be instantiated, and with the help of that object M1, M2, M3, M4, please observe here. You are instantiating abstract class subclass, where you are taking the reference into abstract class subclass only. And same class you are instantiating, and into same class you are taking the reference. In this case, you can invoke M1, M2, M3, M4 and M5 methods. Because you are instantiating and taking the reference of this class into same class itself. So you can invoke all the 5 methods. M1, M2, M3, M4, M5. All 5 methods. Suppose if you instantiate abstract class subclass and take the reference into abstract class. AC is equal to AC means here this abstract class. AC is equal to new abstract class subclass. Is it possible to take subclass object. This is subclass object creation, right? ACSC. Abstract class, subclass. Yes. This is abstract class, subclass object creation. Can you instantiate subclass and take its reference into superclass? It is valid. It is valid. But with this reference, how many methods we can invoke? We can invoke only M1, M2, M3, M4, but not M5. Because if you take subclass object and if you create subclass object and take the reference into superclass, only the methods that are commonly available in both subclass and superclass can be invoked. That is M1, M2, M3, M4 method. Wherever they are implemented, only those methods can be accessed, but M5 cannot be accessed because M5 belongs to the method of abstract class subclass. It is not coming from the abstract class. And whenever you take subclass object into superclass reference, only the common methods like M1, M2, M3, M4 methods can be accessed. M5 method cannot be accessed. If you instantiate abstract class subclass and take the reference into the same class, then you can invoke all the M1, M2, M3, M4 and even including M5 also. After this presentation, I'll update this slide. Okay. So this is regarding the whole abstract class. When to declare, what to do if abstract class is written without abstract methods, why class need to be declared as abstract. They were all discussed here. Important points about abstract class. What happens if class is declared as abstract? What happens if class is declared as abstract? If class is declared as abstract, it cannot be instantiated. Then what we can do? We can do only inheritance. Okay? If at all if abstract class is found, it should be only inherited, it should not be instantiated. And second, whichever class inherited from the abstract superclass must feel responsible to implement all the superclass abstract methods and subclasses. If don't do, compiler will force its subclass to be declared as abstract. What happens if class is declared as abstract? Yeah, finished. Is it mandatory that abstract class must contain abstract methods? Certainly no. As previously I said, the component class, the most generic implementations containing class. The class without having abstract method, the class is declared as abstract. So what to do? So no need. Without abstract methods also sometimes class can be declared as abstract. So for most classes. And then without abstract methods, so where class need to be declared as abstract. More generic classes who provide a common functionality are declared as abstract class. Such classes do not want to be instantiated directly. They allow their methods to be called a subclass object. They allow their methods to be called via subclass object. Here, M1, M2, M3, M4 methods, you are calling from which object reference? Abstract subclass, isn't it? Matter how the abstract class methods are invoked? Via subclass object only. Abstract class. Abstract access modifier is completed. Now we are coming to final. Abstract modifier, see here. This is one nice caption about final. Final prevents inheritance. Immutable class. Final prevents inheritance. Abstract prevents instantiation. Abstracts prevents instantiation. Final prevents inheritance. It's an immutable class. Prevents inheritance means final classes cannot be inherited into subclasses. And then from A, B cannot be derived if A is declared as final. Like that. And then to the final classes, no child classes or subclasses exist. No child hierarchy exists. So when the class cannot be inherited into subclass, its methods cannot be overridden in the subclasses. There is no subclass concept, so there is no concept of inheritance. Because final class cannot be inherited into subclasses and their methods can be overridden, and the final classes can also be called as immutable classes. Immutable means no change. The methods once implemented in the final class becomes final method. They cannot be changed. That is what the meaning of immutable class means. Immutable class means whose methods do not want to be overridden. Not whose methods do not want to be overridden, whose methods their methods cannot be rewritten in any subclasses. Their methods cannot be changed. Suppose if anybody wants to use Only the class can be directly used. The class methods can be directly invoked, but the class whose methods cannot be overridden, modified, changed. Such classes are called as final classes. So we'll see here. Final. Final is quite opposite to abstract. Abstract cannot be instantiated, it can be only inherited. Final cannot be inherited, it can be only instantiated. Quite opposite. The one and only one access modifier we cannot apply at a time on only two access modifiers which we cannot apply at a time on a class or a method is only abstract and final. These two combinations doesn't work. But which access modifier combinations can work mostly are final and static. Final static combination will apply mostly on variables and functions. But final abstract combination is completely a wrong combination because final and abstract both are quite opposite, right? Final is opposite to abstract. So final classes cannot be inherited. It can be only instantiated. Very good. That means no subclasses exist for final classes. No subclass exists for final classes. In Java, abstract classes are also plenty. Final classes are also plenty. So many final classes exist in the Java API. From each package, I can show you 1 to 10 to dozens of final classes. Yeah, that means no subclass exists for final classes. There are so many final classes exist. I'll show you. Almost all wrapper classes in Java are all serializable, including string, buffer, and string builder. And all wrapper classes like byte, short, integer, long, float, boolean, character. All wrapper classes are final classes. So we'll come to the discussion anyway. Right. So that means no subclass exists for final class. And when to declare class as final, that we will discuss later on. When to declare class as final, that we will discuss later on. First of all, we'll see how to write final class and how it can be further used. To write final class, you write like this: public final class, some FC, some name. This name can be anything. ABC exclude can be. Public final class. And it is having M1, M2, M3. Three methods implemented here. These three methods are normal methods, but class is declared as final. Don't know why class is declared as final, that I don't know. We'll see later on. I'll even explain you as however I explained about abstract class. Similarly, I'll explain about final class declaration also. When to declare class as final also, that I'll discuss later on. Once the class declared as final class, you should try to inherit from the final class. How? Public class FCSC. FCSC means, as you already know, final class subclass. Extends final class finish. Class declared as final. That means that is final class is the last class in the hierarchy. No childs found for the final classes. To such a class, if you are trying to inherit, and once you end up as subclass hierarchy to a class, if you are trying to inherit, if you are inheriting from final class, extends final class, immediately you will get an error. You will get an error saying that final classes cannot be inherited. Then what we can do with the final classes? We can only instantiate final class. We can only instantiate final class, and its methods can be invoked. If you are interested, invoke them. If you are not interested, keep quiet. We cannot change the method implementation of any of these methods at runtime. So this is about final class. Final class cannot be inherited. It can be only instantiated and its methods can be invoked. We'll see. This is final class instantiated class, FCIC means. And then where the final class is instantiated. Okay, that's clear. And Java, if you ask me examples on final class, I can give you so many examples of final class, but most frequently seen final classes in Java API are in java.lang package. In java.lang package, all wrapper classes are All wrapper classes are final classes. Like, say, for example, we start from byte, short, integer, long, float, double, boolean, character, string, string buffer, string builder. Wrapper class are 8: byte, short, integer, long, float, double, character, boolean, and other wrapper classes: string, string buffer, string builder. All wrapper classes are final classes. And some other classes may be like math class, whose methods are implemented and calculating to the power of square root to various other minimum, finding the minimum number, maximum number, median number. Those methods are implemented and given in math class. Math class is also declared as abstract. Math class is also declared for final class. And something more. I think URL connection, those classes are also final. INET address class, those classes also will be declared as, or maybe they are also declared as final. And if you ask me the reason why class is declared as final, if you ask me, here is example. For the standardization purpose, some classes implement standard methods which are not meant to be modified. The best example for this statement is if you open command prompt on any JDK, Java software installed machine, you open command prompt and just type Java p java.lang.string. Just type Java p space java.lang.string and see the list of methods implemented and given in string class. String class is having some around 30 to 40 methods in string class, which are like substring, to lowercase, to uppercase, get char, to carry, index of, last index of, starts with, ends with, some other equals method, hash code method, twisting method, and so many other string class methods. So, what string class especially feel is the methods with implementation which I am providing on performing operations on string. Those method implementations which I am providing, the implementations are sufficient for the developer to directly use them in the program. Those methods need not be modified by any developer in subclasses. Those classes need not be derived and those methods need not be overridden, rewritten. Because the substring implementation written and given by the sun, the to lowercase, to uppercase, get char, to carry, those method implementations provided and given by the sun microsystem are self-sufficient for the developer to directly use these methods. Developer need not have to rewrite those method implementations. So, what string class feel is to make it standardization, standard methods. Those implementations are final. Then why should I allow my class to be inherited and override my methods? That's how string class felt to be declared as final. Similarly, string buffer, string builder, and all the wrapper classes: integer, long, float, double, character, boolean, byte, short, everything. String wrapper classes and math class. Maybe URL connection, INET address, those classes also from Java.NET package. Those are all final classes. For the standardization purpose, those classes are given. And second purpose is sometimes a class is declared as final also. Because final class says I cannot be inherited and my methods cannot be rewritten in subclasses. Why? Because sometimes we'll write a class for security reasons. Because sometimes we'll write a class with method implementations which belongs to authentication and authorization related operations. But see, in real time, no application exists without authentication and authorization. User needs to log in with username and password to start the examination or to fill up the form. Authentication, authorization, without that, there is no day of starts for a student or an employee or anybody. Even staff attendance is best example for authentication and authorization. Without punching, without giving biometric, nobody will go into the office. So that is authentication or thumb impression, authorization. You are allowed those two. So in a class, I have written methods whose logic belongs to authentication and authorization. So the class feels like you use my methods, but you don't override my methods. You don't rewrite my method implementations. That's how the class will feel. Some authentication manager, something like that. You write one class with authenticate one method and authorize one method. You authenticate and authorize the user who provided username and password. Those method implementations do not want to be changed. They want to be unchanged. They don't want to be changed. Those implementations want to be final. So in such cases, we can go for a final class or abstract that we'll discuss later on. Similarly, standard GST implementations. See, GST calculation. Previously, there was a tax variation from state to state exists before GST. Now, soon after the GST is introduced, for the list of products belongs to one commodity, one GST tax calculation will be applied. So, for example, for a basic civil supplies, for the basic, household ingredients, for that probably the GST may be 8%. And for the perfumes, there may be a GST of 25 to 30%. If you buy laptops, 25 to 30%. If you go to automobiles like cars or buses or bikes, 25% GST. And for the books, stationery, maybe for few others, there may be an 18% GST. And 8%, 10%, 12%, 15%, 18%, 20, 21%, 25%, 28% GST. That depends on the type of commodity. So the GST will be applied on the prices. So the class which contains the GST implementations do not want to be rewritten in any subclasses. The implementations are common that everyone can use it. So such classes are also declared as final. Companies implement standard salary calculations for different department employees and designation of employees. Salary calculation also do not want to be overridden. Once written, salary calculation should be final, because if you go to HR based sites, they'll tell you what is the difference between basic pay, gross pay and net pay. If you go to Google and just check once how to calculate basic pay, gross pay and net pay, there is a calculation that every HR will follow the same salary calculation. The same salary calculation want to be used in our company also. We don't want to change that implementation. And once written salary calculation implementation in one class, that want to be used by others. That those methods do not want to be overridden by or rewritten by anybody. So such a class are also declared them as final. The next, string and math operations are standard. They do not want to be changed. They are also declared as final. Okay, here we'll see one example. Previously, actually in the previous slide I've shown final class. Class is declared as final and its methods are normally implemented. Final class cannot be inherited. Final class can be only instantiated. But if you come to this class, this is a non-final class. See the heading. Non-final class containing final methods. Selected methods can be declared as final. And the important points I'll write in the heading, that is my habit. Non-final class example. Non-final class containing final methods. Then from that we'll see when to go for final methods. Coming to the non-final class, there is a class which contains 4 methods, M1, M2, they are normal methods. M3, M4, these two are final methods. And in these two methods, we have written some calculate salary and authenticate and authorize. Those methods are implemented in some employee service business component. We implemented 2 methods. One is to check the authentication and authorization. One is to calculate the salary. And those are some other methods given, whose methods can be overridden in subclasses. They are written as normal methods. They are written as normal methods, not as the final methods. And there is a class which contains 2 normal methods and 2 final methods. So the class is not final, remember. So what we can do to this class? The class is not abstract also. If I found abstract, I must decide not to instantiate this class. If I found this class is final, I should not derive from this class. But the class is neither abstract nor final, so it can be both inherited and as well as instantiated. Oh, very good. Class non-final class applies extends non-final class, and there is a class which is derived from this non-final class. M1, M2 methods can be overridden under this subclass. Can override M1 and M2. That is optional. But coming to M3 and M4, but because of if subclass tried to override M3 and M4 methods, M3 and M4 methods cannot be overridden because of final methods. If you try to override final methods in subclass, what happens? We get a compilation error saying that final methods cannot be overridden. Final methods cannot be overridden. I'm providing some method implementations in my class whose method implementations do not want to be rewritten or overwritten in subclasses or declared there or declared as abstract. Or declared as final methods. The other two methods, M1 and M2, those two methods are normal methods, so they can be overridden in subclass. But the point is, here we declare two methods as final, non-final, and two methods as final. The subclass can override these two methods, but cannot override these two methods because of their final methods. So then you will be getting a doubt in which context you will get a chance to declare class as final. For example, is this clear? So if final methods exist, those methods cannot be overridden in subclasses. Non-final methods can be overridden in subclasses. Fine. But tell me when to go for, in which occasion we can go for final class. Means, see here, in our class, all four methods, M1, M2, M3, M4, all four methods are final. Okay? I decided to write all method implementations in my class as final methods. If class contains all methods as final methods, then all methods are final. From such a class, the subclass is derived. But what subclass cannot do is, subclass cannot override any of these class methods because in this class, all methods are final. So, the final class, the subclass don't get chance to override any of the superclass methods because they are all individually final methods. But still, class can be inherited. Those methods cannot be overridden because they are final. So, but here in this class, because we are having four methods we declare as final. Suppose our class is having 50 methods or 100 methods. Like as I told you before, the component class like that, kind of. Suppose my class is having 50 or 100 methods and I want to declare all my methods as final. Instead of declaring all the methods as final, declare all the methods as final, allow subclass to derive but not to override any of your methods. Why don't you declare class itself as final? Why don't you declare class itself as final? If class is final, final class cannot be derived. If final class cannot be derived, none of its methods can be overridden here. And in the root itself, we prevented deriving from the final class. If class do not derive into subclasses, none of its methods can be overridden here. There is no inheritance, so where will you get a chance of overriding it out? When the class declare itself to be declared as final, because its all methods are final. Instead of declaring all the methods as final, the class could decide to be declared as class itself as final. So, if non-final class want all its methods do not want to be overridden in subclass, then we are having two solutions. If non-final class and a normal class want all its methods do not want to be overridden in subclass, two options. Declare your methods are all your methods is final. Still your class can be inherited, but no method can be overridden. Second, declare class itself as final. It cannot be derived. It cannot be inherited. When there is no inheritance, there is no overriding. That's all. Declare all four methods as final. The non-final class can be still inherited, but its methods cannot be overridden. That is one point. Second, instead of declaring all the methods as final, declare class itself as final. Declare class itself as final, then final class cannot be inherited. Instead of declaring all methods as final, declare class itself as final, then class cannot be inherited. When there is no inheritance, there is no overriding. And a class decides its methods not to be there. There is no intention of final. A class decided that none of its methods want to be overridden in subclass. That's it. Then the developer must think of responsibility to choose either of the choices. One is he can declare all methods as final, as I shown previously in a class. Class can be still inherited, but its methods cannot be overridden. Second, declare class itself as final. Final class cannot be inherited. When there is no inheritance, there is no overriding of the method. So this is how we should judge when to declare in a class as final. So in this presentation and including in the last presentation, I hope I have given enough explanation on how to declare and use abstract class and final classes, and when to declare classes abstract and classes final. Methods influence to declare class as abstract. Without abstract methods, also class is abstract. Methods will influence to declare classes as final. Without that, only methods can be declared as final. But one thing, if you declare class as final, class cannot be inherited. And inheritance is one of the features that we will lose if you declare class as final. A class, suppose for example, there is a class A, it's a final class. It is having some 10 methods. I am writing a class B extends A. In the subclass, see here you decide whether you want to declare class as final or methods as final. Class B extends A. Class B is such a class. Superclass is having 10 methods. B do not want to touch any of the methods. B do not want to override those 10 methods. But still, B wants to provide some extra methods in the subclass. And in addition to class A methods, class B wants to provide some extra methods, but none of the already implemented methods want to be changed. Then if you declare class as final, you lose this inheritance. And your class functionalities cannot be further extended. This is called as extending your class functionality. Not rewriting from class functionality, extending class functionality. If you declare class as final, you lose the chance of inheritance. That if somebody wants to provide extra functionalities to your class, and apart from 10 methods, if 10 more methods want to be additionally added, if class is declared as final, because it cannot be inherited. If any class like B wants to provide extra method implementation to your 10 methods, in that class, you need to write all 20 methods. All 10 above superclass 10 methods you see in right here, plus add 10 more methods. 20 methods you need to write here. Because of you lost the chance of inheritance. In this case, instead of declaring class as final, you declare all your methods as final. None of the 10 methods can be overridden here. Only 10 extra methods are added. Still inheritance exists. Or reusability exists. Inheritance exists. Reusability exists. Your 10 methods will remain alive as is, and 10 extra methods are provided. Then in this case, you better declare class methods as final instead of declaring class as final. You don't want to extend your class functionality Whatever methods given in your class, they are final, they are sufficient for the developer to use throughout the development time. You don't want to write subclasses to your class. You don't want to provide extra, and you don't want to allow extendability to your class, adding extra functionality to your class methods. Then you declare your class as abstract. You declare your class as final. This is how, as I see, an object-oriented programmer, by developing applications for years together, will soon become an object-oriented designer and an architect. Those designer and architect teams will judge whether how to declare methods as and classes as and find variables as and constructs. If you're having 3-4 years of experience in object-oriented programming, actually you will get the skill, designing and architecting skill. This is about abstract and final modifiers. In the next video, we'll see the consequences on variables. Until then, thank you. Bye.
Like, share and subscribe. Hit the bell icon for more updates.